Hey Malcolm, you've got a contraption here below me. What is this?
This is the first trial of our technology with coal and...
Coal?
Coal.
Coal?
Coal.
So what, you're just trying to deal with the soot, are you?
Yeah, trying to clean it up, which we did.
Okay.
Under the theory...
It looks like a water heater. I might boil some, soup in or something.
Actually, this is we got this from Germany because we needed stainless steel. So this is a brewer.
A brewer?
It's for brewing beer.
Okay.
Right, so, and this has got a little clip on it, so I can clip my little lid on.
Wonderful.
Right, and we've cut a hole in the top of that, attached our thunderstorm generator, and here we've got our attachment for our vacuum cleaner.
Any particular brand of vacuum cleaner?
We don't have any sponsors as yet, so we're not giving
yeah, sponsors can come later.
Yeah, that's right.
Right. So, just a normal sort of domestic, sort of like what they call a Henry type thing.
Yeah, it's wet and dry.
Wet. Yeah. Okay. All right. Okay. So here we go. Get to see the actual thing. And have you got that in a suck or a blow mode?
Well, that's blowing in under the furnace.
So that's force aerating the coals.
Correct.
Right.
Yeah.
Okay.
So that it burns.
Yeah. Yeah.
So that we can then have it captured and the waste gases captured. They come up here in the normal function. They spin anti-clockwise down the body of the machine, and then out as exhaust.
Hold on. I don't see a sphere at this end. Why?
Because that was cut off in the course of action when the other sphere was necessary. This sphere, if you actually look at it, has actually got the original, I think it's on the other side here, the original, take that there.
Okay.
Original, when it was, we tested it both left and right hand, proving that you can't go clockwise because it doesn't work, because clockwise is the normal state of negative charge in my economy, and so basically imploding clockwise implodes, anti-clockwise explodes, so you're matching up the explosion with its natural spin. So basically then that goes down its natural spin, comes out and then goes out the exhaust. So we just put exhaust onto that. We have the bubbler here is situated in this position.
Yeah.
So the bubbler sits in this position and takes in the, you can see the tubing here.
Hold on a minute. What have we got there? This looks like someone's kitchen pot.
Yes, this is Alpha Prospect's contribution to the involuntary contribution, but in fairness, he did leave it on his stove. So yeah. And
this looks like a modern day Vitalux bulb. What is it? Oh no, is it a heat lamp or a UV lamp? It looks more like a heat lamp.
Well, it's the reptile.
Yeah, it's one of those. Yeah.
Again. So it's one of those. So yes, it's a UV heat lamp.
Okay. Yeah. It's the combo ones. Yeah.
Yes,
okay.
So basically, that simply goes onto there. Then
so that's coming.
The air comes down through here, down to the bottom of the bubbler.
Oh right, yeah, I see. So you've got to feed off from your friend's cooking pot down here.
Correct.
Yeah.
And then it goes down into the bottom of the bubbler.
Copper.
And then the bubbler. Goes counter again. So it comes in here.
Okay. Yeah.
And comes counter. So it spins clockwise through here and out the end.
Lovely. Okay.
So, and this is where we put the vacuum suction.
Right. Okay. So you got two vacuum cleaners,
we
or
suck here and we blow there.
Oh, right. So yes.
So basically, there's another tool goes onto here, which we have here actually, and in fact, I'll probably screw it on because it would have a little device to screw on here.
I'm interested to see what you got going on in the pot here.
Yeah, I'm just seeing the. No, we don't have that. Anyway.
You've basically engineered, I think you've engineered something in here to produce a lot of toxic black smoke, right?
Correct. We have basically, okay, so this is stainless steel, this is our brewer. Inside that we have a Lowe's normal incinerator. Inside that we have the cast iron pots.
Come on, show us.
From South Africa. Okay, so we'll cut this off.
So we got Kyan here and Johanna James, and we are.
Okay. So now here.
They're helping there.
So the outside here, the air, we've got little holes in there in the bottom. See the air comes through.
Oh right,
There.
yeah.
We've actually got the original stainless steel, sorry, not stainless steel, cast iron things to put on the bottom, and so you can see the little remnant of the
So it's basically
pellets,
like a
wood pellets.
blast furnace.
yeah, blast furnace.
Is this the here's one I made earlier? Of
Yes,
Right.
that's the yeah.
Oh right,
it's the
that's getting ready to go. Yeah,
Yeah.
cool.
Yes.
Yeah. That's a brand new unused
that's
one.
the spare.
That's
Yeah,
the
yeah.
When I
spare
thought
one.
I might burn this one out.
Yeah.
Yep. So basically,
So you keep mentioning stainless steel. What's your justification for that?
basically in this case, well, there's several aspects to it. Is that it's durable and the effluent from burning coal is fairly egregiously corrosive.
Right.
For both humans and metal. So basically, we've used this. You see that I drilled holes
Okay,
in the bottom
yeah,
of this
yeah,
pot,
yeah.
right? And
You really wanted a lot of black smoke, didn't you?
yeah, and so then we put. Well, actually, you see the holes that are in it.
Oh yeah.
We don't, it's a good vent.
Yeah,
right?
yeah.
And it burns, and it's burning on top of this stainless steel again. So you can see that it's past a little bit corroded, but if it was iron, it would just be gone by now, probably. But anyway, and you can see inside there's actually remnants of the coal.
Yeah.
Oh yeah.
Right, so we're burning that. The idea is then this is all captured inside here. So basically, we didn't want this to get too hot. Yeah, so it's inside the incinerator, and it's actually the other one there it sits on. Yeah, that guy's sitting there. So this has centered it. So basically then this top here, then interestingly, lines up with our chimney, which is here.
Okay.
So basically, but we have another cap. So that cap goes there.
So this is actually an incinerator. This is like
Correct.
a home
incinerator.
little like. I've got some rubbish and I want to
Mini
get
incinerator.
mini. Okay, yeah. So it's like you can put your backpack in there when you've done a run, yeah, and burn it all. Yeah.
So that was the basic bottom line, and so it had the handle so you could lift it out.
Yeah.
So now this is directing the flow directly to our cap. If so the cap goes onto here.
Where did the cap go?
So
there we go.
yeah. And remember, we've got a vacuum cleaner on this end pulling the
Yeah.
plasmoids and the water in its gas phase.
Yeah.
And this is the genius of it, absolute genius, blowing it into the bed.
Suck and
the
blow.
furnace.
Yeah.
Yeah.
So hold on. So you're actually whatever comes out of there is going fed straight back in again.
Correct.
Okay.
Because
so
what we're doing is we're getting the plasma discharge on the carbon itself.
right.
So similar to the internal combustion engine where we have the interaction of the hydrocarbons and in the combustion chamber, well, this is the same. It's the interaction of the hydrocarbons in the combustion chamber.
And you are feeding the moist air from the bubbler through and into the combustion area as well.
Water in its gas phase
Yeah.
and the plasmoids, yep. And it's charged because, again, it's exactly the same thing. It's a heat waste energy recovery system. And this is now acting in exactly the same way as with internal combustion engine. So, and what we found was that the exhaust coming out there, which we analysed, and with a representative of a public company here in London, that exhaust gas then became, well, three things happened. Number one, it didn't smell. Number two, smoke went. Number three, it zeroed out the carbon monoxide. It zeroed out the carbon dioxide. So not completely zero, there was some percentage left in this, there was a few years ago. And, but anyway, it's basically reacted the same, increased the level of oxygen.
So what you're basically saying is we can all go back to burning coal.
Absolutely, amen.
Thank you very much. So first off, what have you got in your hand there? What's this thing here? It looks like it's been made in some sort of garage and the end of the earth.
This is actually the first model. It's 8 years old, and after 8 years, it still had its plasmoids embedded in it. When we put it by itself, which I can show you what we did, we put it by itself, attached it here, just on there, with no visible means of doing anything except accepting the exhaust gas.
Yeah.
And miraculously, it worked.
Well, they do like to live into metals indefinitely, so.
8 years, we've got a record. We have a record.
Yeah, well, I'm sure there's going to be a Russian out there somewhere that says it's been in the system longer, but
So,
yeah. 8 years is the longest I've heard yet.
Okay, yes. So, and that's not a small machine, because remember we had the other one, which was the spheres in there. But anyway, here's the guy put on the wrong side. We tested it. It didn't work because it's going clockwise. So then we welded it up and put on the other side, and it worked.
Well, there you go.
This is one thing before we move on.
Oh yeah, this is great.
Oh yeah, by the way, Johanna James is here.
Can you see through where there's literally the metal split? Can you see the light through the holes? Maybe. The metal has split inside.
Yeah.
And it was still working
All right.
even with the holes in. But yeah. But then got a magic trick.
Yeah, magnet on there, doesn't stick.
Doesn't work.
Okay, magnet on there.
Where it's imploded.
Well, there you go.
You turn upside down.
Magnetised. Here.
Stainless steel, not magnetized.
And what was the weld in that point? What was it made of, the weld? What's this thing
It
here?
was stainless steel.
Right.
It's all stainless steel.
Because it's really like in that there, isn't it?
Yeah, like where it's imploded.
And what are the welds on here? These are all brazed, right? That's magnetic there. That's magnetic there. So that's the same material?
No, but it's the same thing. You can see that on crystalline. Just put it on there. Put it on here.
That is stainless steel.
Yeah.
Yeah.
It's all magnetic.
But it's going to the weld.
No. It's
Okay, the whole is the whole of it is magnetic.
And along here, this is stainless steel as well. Try this.
Let's see, that's extremely magnetic there.
Okay, but try this.
When I say magnetic, it's ferromagnetic. This isn't actually magnetic. This is the magnet. That is ferromagnetic.
Okay, but just put it along there.
Okay, yeah. So it's not magnetic along here. Oh, that's mild steel.
Yeah,
there.
correct.
That definitely is. Are you sure you've not got some sort of welding material that is?
Well, I mean, you put it on the stainless steel here.
Yeah.
It's magnetic. Shouldn't be magnetic. It wasn't magnetic when we started. Put it that way.
Okay. Well, I'll get the Magnaview film. I brought it with me to see if there's any actual magnetism
But I think
fields
that was
in
going
there.
to be fantastic with that one, because get this, the other one was 144 inches between the two 3-inch spheres.
Yeah.
Right? And it was the south pole there as well, with the plasmoids coming in, which I call the south pole or the female negative end. And then
Well, I've got
the same.
I didn't bring my magnetometer, but I brought one on my phone.
Okay.
so we can look at it there.
So basically, this is a very significant result, because this is a single sphere, and it's done exactly the same. But when you add two spheres, one sphere represents the north pole, positive, male, anti-clockwise spin, explosive, and this one represents the implosive bottom, where the electromagnetic fields are concentrating back into the loop. So something's going on there.
Well, it certainly, if both things are in the same place, like I saw on the big unit,
The other one...
that's repeatability, Malcolm. That's good.
It's repeatability on scales, two
Yeah,
different
yeah,
scales.
yeah.
You have a 24-inch sphere that we've proven that even though I've used these as north and south poles basically as a tool, that in fact this didn't implode on the big 24-inch sphere on the Perkins. This end imploded, which is the proper end. Now this one, completely different, only one sphere, and it's imploded on the same point in exactly the same manner, which is we've repeated an experiment on two different scales. It's fractal. It's a big word, but I'll use it anyway.
Well, it's
I think I know
scale
what that
invariant. The process works across multiple scales, which you should do if it's fractal.
I'm glad someone knows English. I was struggling. So yeah, but that is a really important, even though it's a small experiment, it's fundamentally important. And it's probably worth
So
the PhD.
where was this one here? Was that on this one?
No,
or?
this was basically the inside.
Ah,
This would have
okay.
been here.
So have you replaced the inside of that?
No, this is from a different one.
Oh, okay, okay.
So this would have been inside here. The interesting thing is, we have the other one here somewhere. The other one was unaffected. It was only the inside one that imploded.
Okay, okay.
Whereas the other one was the outside that imploded.
Yeah.
But I mean, again, and as Johannes pointed out, it's caused a failure. And I did, when we were doing the test work in North Carolina, I said to the people, I think we've got a slight leak here, you know, because the results were getting a bit dicky.
Yeah.
And so I thought, well.
So you don't think that this is something to do with the annealing on there, and it's got a different thermal expansion coefficient, and then it just failed at that point? I mean, that could be part of the reason for the failure, but I don't think it's necessarily the reason for the magnetization.
Well, it's pulling itself in.
Yeah.
And the plasmoids embedded in the metal, which creates the electromagnetic field and makes the otherwise non-magnetic stainless steel magnetic. And when they're infused a lot, which this one is, then you can see that the stainless steel is magnetic. And it shouldn't be magnetic.
Ferromagnetic.
Ferromagnetic. Okay.
That's tough.
You-
Strong.
Strong.
Yeah.
So-
There's definitely a thing here, but
But those were meant to be stainless steel welding rods, but in fact, there's no interaction between them. So, I mean, I was very careful about that with the stainless steel because we wanted it to take, obviously. But in this world, it's really interesting because if you look at that colour again, that's a similar colour in the sunshine as we saw in the other one.
Oh, we had a red gold, like.
Yeah.
But,
thank you.